get a little bit better graph. Something real basic, y equals negative 5x squared. Graph this. Okay, so you look at the graph. Once again, as I did with the uh, linear functions, my domain meter, they go along the x-axis, it's going to be beeping the whole time, even when I move over, even though it doesn't look like I'm going to have anything at 15. I just scroll down, move my graph down, it eventually will cross over. It gets really big numbers, but there's still a value when I plug 15 into my function. And the same goes for everything. Even if I put 1,000 in for x, my number is going to be very, very large because I'm squaring it and multiplying it. But I still won't get the value. Okay? But what about my range? My range, as I'm going down, you should see, as we said before, with end behavior, it's going to go down forever. But as I move my range meter up, it's beeping, 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 but then it stops beeping. There's nothing above this point. There's no beeping above because there's no graph above. So my range stops right here. In this case, my vertex is 0. So that's the highest point. So basically my range can be anything lower than 0 and 0. And a good way of saying that domain is all real numbers. The range is all real numbers less than or equal to 0. Okay? That's not on purpose, but we look at this next one. All right, so y equals x squared minus 5x minus 6. I graph this guy. Make things a little bit confusing for you. Apologize. All right. So we know that since a value is positive, we have a U-shaped parabola. Okay, so here's my graph. And same thing with the domain, right? And if I go across, keep going, we're going to always have values for x. Same thing, it's going to keep getting bigger and bigger, but I still can plug any x value I want into this equation, this function. Okay? But my range meter, if I start down here, there's nothing beeping at all until I hit right around here. And then it's going to beep forever as it continues to go up and up and up and up and up. So I want to find what this value is, what the vertex is. All right, so finding that vertex, we know how to find it. Now, this will let me find the vertex, find extreme. So extreme values means minimum values or maximum values. So let's see how long it takes the computer to do this. All right, well, I'll put it back down here. So it says no maximum values. There we go. No maximum values and has a minimum value. Minimum value at negative 12.25. So 2.5 is my x value for the minimum, and my y value is negative 12.25. That's the vertex. Okay? And since I'm dealing with the range, all I care about is the y value. What's the y value right here? It's saying negative 12.25. If you wanted to, you could do negative b over 2a and then plug that in and actually find it. It's a little bit too much work for us right now. Okay, so negative 12.25 is a low value. It actually reaches there, and then everything else is above it. So my range, in this case, will be all real numbers greater than or equal to 12.25, because it can equal this and all numbers that are greater than it. It will pass through. Okay? Right. And then finally, different formats. All right? It doesn't really matter that it's in a different format. Vertex form. And let's look at graph. Vertex form actually will be a lot easier for us because the vertex is the key to finding domain and range with our quadratic functions. Um, as you see in this case, it looks very similar to the last problem. It's a different graph though. Domain, once again, is going to have all real values going left to right. Continue going up on both sides forever, but it has a low point here. So there's something that zoom in, you can zoom in, and how are we going to find that? It looks like it's right at 3. Oh, hey, second, 3. 3 is my vertex form, 3, -4. So this value is 3, -4, which tells me my low value is -4 and everything above. Okay, so hopefully you can write the domain range at this point. Domain, all real numbers. Range, all real numbers greater than 40%. And for vertex form, it's very nice. It's right here in my equation. Okay, that's quadratic functions, domain, and range. What I want you to think about, since we just finished up polynomial functions, is domain and range for polynomial functions in general. So linear functions and quadratic functions are both polynomial functions. But in general, what values can I plug into x? What values can I get for y for my range? All right. The thing that you want to think about are what your graphs look like. I think that's probably the easiest. That's how I have to visualize my graphs, what they're going to look like for polynomial functions. Use your knowledge of M behavior, number of zeros, etc., to help you think about domain and range. M behavior is the key part. All right, the number of zeros, sure, that might have a little bit depending on some parts, but M behavior is the big thing. So if you think about a linear function, what the end behavior was, and what happened with your domain and range, versus a quadratic function, what your end behavior was, and what happened with your domain and range. And think about how that translates with x to the third, x to the fourth, x to the fifth, x to the sixth, so on and so forth. So I want you to think about that and come in with some ideas as far as what domain and range would be for polynomial functions. All right? Hope I didn't bore you too much, and hopefully you're staying safe in this weather, getting out of the house a little bit. All right? See you when we get back.